Hello, everybody. This is John with Gringo CTO. Today, I thought I'd try something a little bit different and review an article. Um, Pretty important one, I think. It was making the rounds about a year ago. I think kind of capturing that collective consciousness a little bit about, hey, we can actually start using SQLite for some stuff that's not just tests. Um, by a really accomplished author named Ben Johnson. This is on the Fly.io blog. I don't personally have anything running in prod on Fly.io right now, but it is an interesting service. So, for context, their whole hook is they run your applications. I'm not sure if it's actually on the edge, but it's a similar idea. They live close to your users, and instead of it just being your static assets, images and things like that, it's everything, your application servers as well. And so they have something of a vested interest in keeping as much of your application living close to your users as possible, because that makes their service more valuable, I guess. So just keep that in mind when I'm reviewing stuff. I guess it might be kind of like the disclosure that I'm going to give on their behalf. But of course, I have no involvement with them whatsoever. In any case, I'm all in on server side SQLite is the title. We'll see if I'm in agreement by the end. But Ben Johnson's the author, interesting guy. Like I said, very accomplished. He built a tool called Litestream, and Litestream is, I would argue, one of the missing pieces that makes SQL side server-lite possible. Maybe we'll talk about that a little bit because I think it comes up in the article. But anyway, let's start here. So the conventional wisdom of full stack applications is the N-tier architecture. I've not heard that term in quite a while, which is now so common that it's easy to forget it even has a name. It's what you're doing when you run an application server, nice scare quotes there, like Rails, Django, or Remix alongside a scare quote database server like Postgres. Interesting that he picked up on Remix there instead of Next.js. Although I guess maybe a year ago when this was written, Remix was more of the all-in on SQL side JavaScript or TypeScript more so than Next. But in any case, according to the conventional wisdom, SQLite has a place in this architecture as a place to run unit tests. That's actually a pretty good frame. I think for most of its history, SQLite has been, I think there have been practical applications. It's been used for all sorts of stuff, but at least within the web ecosystem, people saw it as a thing to run your tests on, which is ironic because it's actually not very good for that if you were going to be running a different database in prod. By all means, if you're going to run SQLite in prod, I suggest you run your tests on SQLite. But if you're going to do MySQL or Postgres, I mean, there are enough differences there in the SQL dialects and behavior that I would suggest that you just run your actual database locally. In any case, the conventional wisdom could use some updating. Probably agree. I think that for many applications, production applications with large numbers of users and high availability requirements, SQLite has a better place in the center of the stack as the core of your data and persistence layer. It's a bold statement. And he does say it's a big claim. It may not hold for your application, but you should consider it, and I'm here to tell you why. A brief history of application databases. 50 years is not a long time. In that time, we've seen a staggering amount of change in how our software manages data. True enough. In the beginning of our story, back in the 70s, there were CODS rules defining what we now call relational databases, also known today as databases. Very good. You know them even if you don't. All data lives in tables. Tables have columns, and rows are addressable with keys, CRUD, schemas, a textual language to convey these concepts. For a second there, I thought we were in some sort of 60s beat poem. The language, of course, is SQL, which prompted a Cambrian explosion of SQL databases from Oracle to DB2 to Postgres to MySQL throughout the 80s and 90s. It hasn't all been good. The 2000s got us XML databases. Thank God I've never had to use one of those. But our industry atoned by building some great columnar databases during the same time. By the 2010s, we saw dozens of large-scale, open-source, distributed database projects come to market. Now anyone can spin up a cluster and query terabytes of data. That's actually very true. I think the accessibility of data to more people is one of the best things about the times that we live in. As databases evolve, so too do the strategies we use to plug them into our applications. Almost since COD, we've divided those apps into tiers. First came the database tier. Later, with Memcached and Redis, we got the caching tier. We've got background job tiers, and we've got routing tiers and distribution tiers. The tutorials that pretend that there are three tiers, but we all know it's called N tier because nobody can predict how many tiers we're going to end up with. Actually, that's an interesting point to pause. So I will say that there's a movement among certain people to put everything in the database tier, practically speaking. And so the argument for that would be something along the lines of why do I need a caching layer when if I have everything in my database, I don't need to make a network round trip between my application and my database to begin with. Everything is right there. It's in memory or close enough to being in memory. And so the latency is going to be super low. Everything is close and I just don't need it. So bye bye Redis. Um, yeah, it's not a terrible argument, actually. I do think that time has shown that splitting off your application logic from your data is probably a good practice. Again, conservation of complexity. Things like authorization and stuff like that have to live somewhere. And in general, it's great to have that stuff in source control with processes and conventions that are well understood by the average person you're going to be working with. Not to say that a project like Supabase is not interesting, and I do give them a lot of credit for creating a product that has at least a clear exit path. So if you're going to start with the one tier architecture where everything is in Postgres, at least you have a path to gradually hoist those pieces out. But given that it's not that much harder to do things in the in tier way nowadays with the right tools, and actually I think that my point here is that SQLite does make that easier in a lot of ways. Maybe it's not worth it for your use case. I mean, there are good trade offs and bad trade offs. Saving a day of setup to have a system that can scale a lot further might actually be the right way to go. So in any case, moving on, you know where we're going with this. Our scientists were so preoccupied with whether or not they could and so on. That's funny. Oppenheimer just came out. See, over these same 5 decades, we've also seen CPUs, memory, and disks become hundreds of times faster and cheaper. A term that practically defines database innovation in the 2010s is big data, but hardware improvements have made that concept slippery in the 2020s. Managing a 1 gigabyte database in 1996, a big deal. In 22, run it on your laptop or a T3 micro. Yeah, that's true, actually. I will say, though, that the data has gotten so big. It's like anything, like your appetite also grows with the amount of food that is around you. And I think that, yes, it is much easier to scale data than it may have been in the past, but also our demands on that data have gotten a lot larger. Um, so the kinds of problems have changed. Conservation of complexity again. Um, when we think about new database architectures, we're hypnotized by scaling limits. If it can't handle petabytes or at least terabytes, it's not in the conversation. But most applications will never see a terabyte of data, even if they're successful. We're using jackhammers to drive finished nails. That's actually a good point. I think most applications are not going to see anywhere close to a terabyte of data. I mean, there's a reason that PlanetScale's free tier is 10 gigabytes, I think. They probably concluded that most apps will never get that far, and the ones that do will probably go way beyond 10 gigabytes and be worth a lot of money. I suspect that's what the analysis was like. But um, yeah, I mean, I'm all for choosing technologies that will you scale pretty far, but I also think it's kind of silly to think about scaling to many thousands of requests per second when you haven't even made a sale. So it's interesting to think about SQLite in that context and see how far it can go. The suite release of SQLite, there's a database that bucks a lot of these trends. It's one of the most popular SQL databases in the world, in fact. So standardized, it's an official archival format of the Library of Congress. Didn't know that. It's renowned for its reliability and its unfathomably encompassing test suite, and its performance is so good that citing its metrics on a message board invariably starts an argument about whether it should be disqualified. Yeah, I think I've seen some of those arguments. I probably don't have to name it for you, but for the one person in the back with their hand raised, I'm talking about SQLite. This may come up later. It's a long time ago since I read this article the first time, but the thing about whether it should be disqualified, that's kind of the is it just playing a different sport than the other competitors? And the big difference in performance between SQLite, maybe I'm spoiling a little bit, is that because you have a direct connection to what is essentially just a file on your machine, and it is in process, it's ridiculously fast, like nanoseconds or something to access data. And so I mean, there's just very little latency to get data. And in the past, the trade-off was always that concurrency was not very good. So you could use it for a toy, but not for anything serious. And I think skipping ahead to the end, the idea here is going to be that, well, you can use it for more. SQLite is an embedded database. Again, just a file. It doesn't live in a conventional architectural tier. It's just a library linked into your application server's process. It's the standard bearer of the single process application, the server that runs on its own without relying on 9 other sidecar servers to function. I actually think that this is probably the best argument in favor of running SQLite. I mean, it's great that it's extremely fast, but it's the fact that I don't have a dependency anymore. I just have a file. And in a case where you want or need to run this on a VPS or your own bare metal server, whatever it is, for whatever reason, the operational reduction in overhead that that topology allows for you is just so nice. Um, I got interested in these kinds of applications because I built databases. I wrote BoltDB, which I am not familiar with personally, which is a popular embedded KV store in the Go ecosystem. Interesting. So KV SQLite from Go, I guess. I'll have to check that out. I like Go. BoltDB is reliable, and as you'd expect from an in-process database, it performs like a nitro-burning funny car. But BoltDB has limitations. Its schema is defined in Go code, and so it's hard to migrate databases. You have to build your own tooling for it. There isn't even a REPL. If you're careful, using this kind of database can get you a lot of performance, but for general purpose use, you don't want to run your database off the open headers like a funny car. I thought about the kind of work that I'd have to do to make BoltDB viable for more applications, and the conclusion I quickly reached was that's what SQLite is for. Interesting. SQLite, as you are no doubt already typing into the message board comment, is not without its own limitations. That's true. The biggest of them is that a single process application has a single point of failure. If you lose the server, you've lost the database. That's not a flaw in SQLite. It's just inherent to the design. And that historically was the biggest objection to using SQLite. If your server gets corrupted, you just lose all of your production data. And that's one of those technical mistakes that can actually destroy a company. So it is important to think about. Enter Litestream. This is the part I was waiting for. There are two big reasons everyone doesn't default to SQLite. The first is resilience to storage failures, and the second is concurrency at scale. And to highlight that a little bit, I think about 10 years ago, SQLite added something called the wall write-ahead log. I think it's still disabled by default, and you have to enable it. But in any case, it basically is just another sort of like temporary file where things are written ahead of time before they are committed to your database, which is again a file. So in the past, you would essentially lock the file, so your entire database, for a write, and that would block reads as well. Now you have the wall, which allows you to write while the rest of the application can still read from the data that's been committed. And I'm not going to spoil it. If I recall, Litestream slots somewhere in the wall. Okay, so Litestream has something to say about both concerns. How Litestream works is that it takes control of SQLite's wall mode journaling. There we go. In wall mode, write operations append to a log file stored alongside SQLite's main database file. Readers check both the wall file and the main database to satisfy queries. Normally, SQLite automatically checkpoints pages from the wall back to the main database. Litestream steps in the middle of this. We open an indefinite read transaction, interesting, that prevents automatic checkpoints. We then capture wall updates ourselves, replicate them, and trigger the checkpointing ourselves. So if I'm understanding that correctly, it essentially intercepts things that would have gone in the wall. So it's a wall replacement that then does some other stuff that I'm sure they're going to explain to us. A little aside here, the most important thing you should understand about Litestream is that it's just SQLite. I mean, other than the wall, it sounds like. But your application uses standard SQLite with whatever your standard SQLite libraries are. We're not parsing your queries or proxying your transactions or even adding a new library dependency. We're just taking advantage of the journaling and concurrency features SQLite already has in a tool that runs alongside your application. For the most part, your code can be oblivious to Litestream's existence. Or think of it this way. You can build a remix application backed by Litestream replicated SQLite, and while it's running, crack open the database using the standard SQLite REPL and make some changes. It'll just work. You can read more about how this works here. Sounds complicated. It does sound a little bit complicated, but it's incredibly simple in practice, and if you play with it, you'll see that it just works. You run the Litestream binary on the server your database lives on in replicate mode, and then you can restore it to another location. Yeah, so essentially they're just saying you run this Litestream process alongside your application, and it essentially streams it Like they use the verbiage restore, but if I'm understanding how it works correctly, it'll take your changes in flight and essentially stream them to a destination, which in this case looks like S3. Now commit a change to your database. If you restore again, then you'll see the change on your new copy. The ordinary way people use Litestream today is to replicate their SQLite database to S3. It's remarkably cheap for most SQLite databases to live replicate to S3. That by itself is a huge operational win. Your database is as resilient as you ask it to be and easily moved, migrated, or mucked with. By the way, I mean, I'm all for Litestream. I would also say like it's probably worth having a traditional backup process as well, just in case you completely hose your Litestream config somehow and end up writing garbage to your Litestream destination. So if it were me, I would probably have a backup for the backup. But in any case, but you can do more than that with Litestream. The upcoming release of Litestream will let you live replicate SQLite directly between databases, which means you can set up a write leader database with distributed read replicas. Oh, that's interesting. So to unpack that a little bit, uh, there are multiple ways you can design a distributed system. Um, but one of the simpler ways to start sharding or distributing your data is to have replicas for reading data that can live close to users. Again, this is fly.io, and that's kind of what their model is. But then you have only one write leader to preserve consistency. So the idea is that it's sort of the primary. It receives all the writes and then it distributes those writes to the replicas. And so the replicas, I suppose, would be a little bit eventually consistent depending on how you set it up. But that's one of the simpler ways to architect a system like that. So read replicas can catch writes and redirect them to the leader. Oh, so that's interesting too. So you could send the write to whatever node happens to be closer to the user and then forward that to the primary. Most applications are read heavy, true. And this setup gives those applications a globally scalable database. Interesting. So yeah, I do think there's still a point where you would want to use something that's really designed for that distribution. But the fact that you probably could go very far with this architecture, in all reality, probably much farther than 99% of applications would ever need, is quite interesting in my view. You should take this option more seriously, probably. One of my first jobs in tech in the early 2000s was as an Oracle Database Administrator, DBA, for an Oracle 9i database. Interesting. I wonder what Oracle 9i was all about. I remember spending hours poring over books and documentation to learn the ins and outs of the Oracle database. There were a lot. The administration guide was almost 1,000 pages, and that was just one of over 100 documentation guides. Learning what knobs to turn to optimize queries or to improve writes could make a big difference back then. By the way, so on this topic, I mean that is kind of the let's call it the consulting big corp consulting model. They will build or otherwise distribute technology to customers, knowing that the big money is to be made in um, supporting that software over time. And back in the old days, well, that was something that a lot of people did. You build a product that can do theoretically anything, but is very difficult to configure, and then you make a fortune consulting on the problem that you essentially created. But moving on. Learning what knobs to turn to optimize queries or to improve writes could make a big difference back then. We had disk drives that could only read tens of megabytes per second, so utilizing a better index could change a 5-minute query into a 30-second query. I have seen that actually, or even more dramatic. It turns out that knowing SQL is one of the hidden talents that can make your applications effectively much faster. Like a lot of application slowness is really just poorly optimized SQL. But database optimization has become less important for typical applications. If you have a 1 gigabyte database, an NVMe disk can slurp the whole thing into memory in under a second. True. As much as I love tuning SQL queries, it's becoming a dying art for most application developers. I agree that it probably is becoming a dying art, but I disagree that it probably should be a dying art. Um, I don't know that you need to be capable of writing highly tuned SQL by hand, but I think understanding um, to an intermediate level the problems that lead to, let's call it like the 80% worst queries and how to avoid them is, in my opinion, just table stakes for somebody who wants to be a professional developer. and something that I hire for personally. Even poorly tuned queries can execute under a second for ordinary databases. Modern Postgres is a miracle. I agree. I've learned a ton by reading its code over the years. Can't say I've done that. It includes a slew of features like a genetic query optimizer. What the hell is a genetic query optimizer? Now I'm curious. Row level security policies. Whether you should use those is a different question, and a half dozen different types of indexes. If you need those features, you need them, but most of you probably don't. Yeah, that's true. I would say that there's a spectrum of, let's call it featurefulness, with SQLite on the low end and Postgres on the high end. I'd put MySQL somewhere in between, but probably a bit closer to Postgres. Um, Featurefulness is one of those things that cuts both ways. If you absolutely need a feature that product offers, and of course you do need it, as he's saying here. If you don't, though, it's one more thing that can go wrong usually, and so there is something to be said for simplicity. If you don't need the Postgres features, they're a liability. Hey, what I just said. For example, even if you don't use multiple user accounts, you'll still need to configure and debug host-based authentication. You have to firewall off your Postgres server, and more features means more documentation, which makes it difficult to understand the software you're running. The documentation for Postgres 14 is nearly 3,000 pages. Didn't know that. But yeah, I mean, the point here is basically if you were paying a premium to have somebody else manage all of your infra, or you have somebody whose job it is full time to manage that. I mean, this doesn't matter to you. If you are, though, like kind of an indie hacker type and you're putting together something on the side, you want to move quickly, but you want to be stable enough, something that you can grow from. Maybe you don't need all of this and it's going to take you some days to set up and configure that you just don't have. SQLite has a subset of the Postgres feature set, but that subset is 99.9% of what I typically need. I pretty much agree with that. SQL support, windowing, CTEs, full text search, JSON. Yeah, I mean, honestly, these are probably about as advanced as most people are ever going to need. Sadly, a lot of developers I know just have no idea how to use window functions, and they're absurdly powerful. And I should probably do a video on those. But anyway, and when it lacks a feature, the data is already next to my application. True, so there's little overhead to pull it in and process it in my code. Meanwhile, the complicated problems I really need to solve aren't really addressed by core database functions. Instead, I want to optimize for just two things: latency and developer experience. Yeah, makes some sense. So one reason to take SQLite seriously is that it's operationally much simpler. I agree. You spend your time writing application code, not designing intricate database tiers. But then there's the other problem. The light is too damn slow. That's kind of funny. We're beginning to hit theoretical limits. In a vacuum, light travels about 186 miles in 1 millisecond. You know it's an American audience because they're using miles. That's the distance from Philadelphia to New York City and back. Add in layers of network switches, firewalls, and application protocols, and the latency increases further. The per query latency overhead for a Postgres query within a single AWS region can be up to a millisecond. That's not Postgres being slow, it's you hitting the limits of how fast data can travel. So the argument here is it doesn't matter how much you optimize. It's funny, I always call this the speed of light argument. In this case, we're actually talking about the speed of light, but it's an understanding of how fast could you possibly go to sort of bound how much you can improve something. And yeah, in this case, we're talking about there is just a limit on how performant your queries can be if you have to reach out to the network, travel at the speed of light, and then make a round trip. And the fact that the SQLite database is going to be living right alongside everything else in your application inherently just means it's going to be faster, at least in that sense. A dozen database queries and you've burned over 10 milliseconds before business logic or rendering. I mean, that's true. You could also probably architect those queries to consolidate a little bit more. But in any case, there's a magic number for application latency. Responses in 100 milliseconds or less feel instantaneous. Snappy applications make happy users. 100 milliseconds seems like a lot, but it's easy to carelessly chew it up. The 100 millisecond threshold is so important that people pre-render their pages and post them on CDNs just to reduce latency. Yeah, I mean, that's true. There is something magical about having something just feel instantaneous. I will also say, though, some of the onus there is just on devs to build interfaces that perform well, even in the absence of snappy connections. We'd rather just move our data close to our application. How much closer? Really close. SQLite isn't just on the same machine as your application, but actually built into your application process. That's true. When you put your data right next to your application, you can see per query latency drop to 10 to 20 microseconds. That's micro with a, what is that, new in Greek letters? I think so. A 50 to 100, a 50 to 100x improvement over an intra-region Postgres query. But wait, there's more. We've effectively eliminated per query latency. Our application is fast, but it's also simpler. We can break up larger queries into many smaller, more manageable queries. It's been the time that we've been using to hunt down corner casey N+1 patterns building new features. Minimizing latency isn't just for production either. Running integration tests with a traditional client-server database easily grows to take minutes locally, and the pain continues once you push to CI. That is true. Reducing the feedback loop from code change to test completion doesn't just save time, but also preserves our focus while developing. A one-line change to SQLite will let you run it in memory so you can run integration tests in seconds or less. Again, another operational win. Just the fact that it's just a file is helpful in a lot of ways. Small, fast, reliable, globally distributed. Choose any four. Litestream is distributed and replicated, and most importantly, still easy to get your head around. Seriously, go try it. There's just not much to know. That's true. I mean, it really is just a command that you run alongside your app, and it streams stuff to a destination. I don't think they mentioned it here. I think it's S3 compatible, SFTP, really just about any destination. I think there's a driver for it, so it doesn't even just have to be S3. But my claim is this: by building reliable, easy-to-use replication for SQLite, we make it attractive for all kinds of full-stack applications to run entirely on SQLite. It was reasonable to overlook this option 170 years ago when the Rails blog tutorial was first written. Still, to be fair, one of the best just sort of promotional materials for a framework I've ever seen. Classic. But SQLite today can keep up with the write load of most applications, and replicas can scale reads out to as many instances as you choose to load balance across. Litestream has limitations. I built it for single node applications, so it won't work well on ephemeral serverless platforms or when using rolling deployments. That's true. So this is definitely more oriented towards the VPS. But I mean, a lot of these columns like Docker container hosts have persistent volumes that I should be compatible with this too. I think they are. It needs to restore all changes sequentially, which can make database restores take minutes to complete. We're rolling out live replication, but the separate process model restricts us to coarse-grained control over replication guarantees. To be honest with you guys, I would probably only use this for as long as everything was comfy on a single node, and as long as I was okay with downtime when I needed to deploy or change the schema or something like that. The moment I start having to do things like replicate stuff across multiple nodes and try to ensure some degree of consistency, I mean, at that point, I would probably just bite the bullet and migrate to MySQL or Postgres. But that's me. We can do better. For the past year, what I've been doing is nailing down the core of Litestream and keeping a focus on correctness. I'm happy with where we've landed. It started as a simple streaming backup tool, but it's slowly evolving into a reliable distributed database. Now it's time to make it faster and more seamless, which is my whole job at Fly.io. Well, it's awesome that that's his job. There are improvements coming to Litestream, improvements that aren't at all tied to Fly.io that I'm psyched to share. Litestream has a new home at Fly.io, but it is and always will be an open source project. My plan for the next several years is to keep making it more useful, no matter where your application runs, and see just how far we can take the SQLite model of how databases can work. So cool. My thoughts on this in general, great write-up. He's obviously passionate about his project. It's a cool project. I think it has like 9,000, 10,000 stars on GitHub now. And it's exceedingly easy to use. So to me, like I think the use case for Litestream is essentially overlapping with the use case of SQLite in production. If you're going to use SQLite in prod, you better be securing your data somehow. And yeah, I mean, Litestream seems like about as simple a way to do that as you could ask for. I don't really see this as being a great solution to the whole multi-node or distributed data problems. And as I mentioned earlier, like I probably wouldn't use SQLite in that scenario, honestly. There's a limit. I think the overall argument of this piece is that the limit is much higher than thought. There's a project called Pocketbase that I think is quite interesting, kind of like a Firebase in Go that uses SQLite for storage, fully self-hosted and everything. Very cool project in its own right. That is dependent entirely on SQLite. The numbers that they're always quoting are 10,000 concurrent users and 500,000 users total. So, you know, kind of assume maybe like halfway along that path, you might want to consider migrating to something else. To me, the bigger choice is between relational or non-relational, like Mongo. And once you're in sort of the relational world where your data actually has relationships, there's tools like PG Loader to make migrating from SQLite to Postgres less painful and stuff. So before I seriously considered relying on like a V0 point something tool, which is not Litestream, it's stable, but one of the other options that attempts to make SQLite replicate across multi-nodes and stuff like that, I would probably just migrate to a real server at that point, whether it's Postgres or MySQL or MariaDB or whatever, something designed. Use the right tool for the job, in other words. But yeah, like as far as what you could use as a backend for your next side project, I mean, hard to argue against this in SQLite. I mean, just ask yourself, when was the last time that you launched a side project that actually got 500,000 users? And I think for most people, that's going to be enough runway to figure out what you want to do. So in any case, I think the point of this piece was think about SQLite on the server side if you haven't already, or that you should be thinking about it more. All in might be a little bit of a strong statement, but I think as far as an option that has a low operational overhead profile, very easy to understand, very easy to operate in a CI/CD environment, and so on, while still preserving a lot of the ergonomics of working with a traditional SQL database. It's a very strong option. I'll put it that way. So in that sense, I'm in complete agreement with the author. But all right, I think that's all for today. Thanks for watching. Any suggestions for other videos or feedback on this one? I'm curious. This is a format that's useful for people, just to kind of review interesting things that have happened or may happen in the future. But assuming you liked it, like, subscribe. It's a new channel. Every little bit helps. Thanks so much.